Charles and Boyle's Law by James and Jack. First is Boyle's Law. Robert Boyle discovered this law in 1660 while studying the compressibility of gases. Boyle discovered that pressure times volume equals a constant by using an experiment he created involving a piston, a bath of water, a constant heat source, and a mass. Properties discussed. The pressure and volume have an indirect relationship in Boyle's law only when the moles and temperature remain constant. This means that when the particles hit the walls harder, there is less space for them to move around in. Or when they hit the walls less hard, there's less room for them to move around in. Again, this is only when the moles, which is the amount of particles, and temperature, which is controlling how fast the particles are moving, are constant. The variables involved in Boyle's law. The definition for Boyle's law is for a given amount of gas at a constant temperature, pressure times volume always equals the same number. At a fixed temperature, the volume of a gas is inversely proportional to the pressure exerted by the gas. In the equation PV equals nRT, the temperature is constant in Boyle's law, as you can see by the diagram. Boyle's law in the real world. An example of Boyle's law in the real world is a syringe. When the plunger is pulled, it causes the volume within the chamber to increase. Since the chamber is increasing, there is more room for the particles to move around inside the syringe. This creates a vacuum of sorts in an attempt to increase the pressure, ATM. Then, whatever is in the syringe, which is most commonly a liquid, gets sucked into the chamber, reducing the amount of space the particles have to move around, and increasing the pressure back to normal. This means that the particles will be back to hitting the walls harder and more often. Demo for Boyle's law.
Take a clear bottle and fill completely with water.
So you can show like that on there, right? And then put it
Take your ketchup packets and stick through the top of the bottle. Put the cap back on the bottle. Carefully watch as we squeeze the bottle. The ketchup will sink. The volume of the bottle is pressurized by squeezing it, therefore changing the volume of the ketchup packet and causing it to sink. But when released, it is repressurized and adding more volume back to the packet, causing it to float.
History of Charles' Law. Years after Boyle discovered Boyle's Law, Charles discovered Charles' Law in the year 1787. In his experiment, he observes that at a fixed pressure, the volume of a gas is proportional to the temperature of the gas. Charles discovers that V over T equals constant by using a piston, a bath of water, a constant heat source, and a mass. So, how does this work on the molecular level? When a given amount of gas is held at a constant pressure, the volume is directly related to the amount of temperature. This means that when the temperature increases, the molecules will be moving a lot quicker, hitting the walls of a given container more often and with more force, creating a bigger volume. Properties discussed in class. In this law, the volume is directly related to the amount of pressure. As one increases, the other does as well, and vice versa. This being the case, the amount of moles and pressure must remain constant. The only thing that changes is the volume, temperature, and the movement of the molecules. The faster the molecules are moving, the bigger the volume and the higher the temperature. A real-world example. One example where this can be seen in all of our lives is when you leave a basketball outside in the cold, it will become flat. This is due to Charles' law. The basketball is held at a constant pressure while the temperature drops. The molecules inside the basketball slow down, allowing air to escape. Thus, when the air escapes the basketball, the volume decreases and you are left with a flat ball.
The relationship between Charles and Boyle's law. The differences between Boyle's law and Charles' law is what remains constant. In Boyle's law, the temperature and the moles must remain constant, but for Charles' law, the moles and pressure must remain constant. This ultimately affects what changes in different experiments. Boyle's law is the indirect relationship between pressure and volume, meaning that if the pressure is high, the volume is low.
Charles' law is the direct relationship between volume and temperature, meaning that if the temperature increases, the volume is increased as well. Some similarities of these two gas laws is precisely that they both need a constant for the equation to be true. Another is that they are both gas laws.
This is a demo for a Charles' law experiment. So, as you've all probably come across, when you're playing ping pong, you might accidentally crush a ball. Well, the way to fix this is by placing it in a pot with some water and heating it up on a stove. So, I will begin to place the ping pong ball in the water. Over time, the ping pong ball will become its normal size again. This happens because the temperature from the stove will heat up the molecules inside the ping pong ball, and the molecules will start to begin to move a lot quicker, hitting the walls faster inside the ping pong ball. So, like I said, over time, it will make the ping pong ball expand again.
Let me know before I was famous. I had too much sauce. All of my heel blow now. That's too much sauce. That's too much sauce. Got too much sauce.